Good afternoon. I'm going to take some time to talk about how we handle power quality complaints. If a member calls us, there's a reason. She's noticing something. So I want you to imagine that Mrs. Smith calls and the report is that every time she operates her blow dryer in her bathroom, the lights dim on one part of the house and get bright on the other. And we can duplicate that right here. Now this is my super duper blow dryer, but when we work those trouble calls and we visit with the customer and she offers us the symptoms, the first thing that we do is go to the truck and we get our PPE. We get our hard hat, our rubber gloves, and a good voltmeter. This is a residential 12240, so we're allowed to use short cuff gloves. So let's start out this demo with our PPE on. We'll put on our small rubber gloves. And usually by this time we've asked Miss Smith to go in the house, take a cup of water and put it in her microwave and turn the microwave on for 5 minutes. And that'll give us time to look with our voltmeter and try to identify the problem. But this particular time, Miss Smith does exactly what we asked her to do. And we can't see it. So by this time, we'd have our meter out. And if these voltage complaints become difficult, we have our voltmeter, we have some type of load that we can add. The super duper heat gun does about 12 amps. We have a load box. This is the Flicker Buster Mini. Does about 20 amps on 120 volts. And then we have the original 50 amp device where we can add 10, 20, 30, 50 total on 120 volts. And 50 amps at 120 volts makes it pretty easy to find that bad connector, voltage drop, whatever turns out to be the problem. But it's large, inconvenient, you don't always have it with you. You may not have this one with you. We take our source for load. We can pigtail into the meter socket, test back through the riser and back to the transformer connections, and we can deliver an external load that's not part of the house, and we can put all of it on one leg so that we force that neutral to take that full 10 or 12 amps. And usually this is pretty effective. When no one's home or we cannot get enough imbalance, can't get enough current draw. We're left with, we didn't find it, call an electrician. Now more than once, that's came back on us because somebody else found it. Now today what we're going to do is demo the Super Beast. This is H.J. Arnett. Product's been around for a while. Every trouble truck in San Antonio has this device. For the kit that we bought the Super Beast Pulse, and we bought the meter socket adapter. The P in the Super Beast P means that when we flip it over to P, we're pulsing. And if you needed to hunt down an underground load back to a load limiter, and you had 4 or 5 running in this pedestal, this would be a way. But for what we're going to use it for, we've taken all the tools, this external load, the voltmeter, all those things, Mrs. Smith, and we put it in to the Super Beast. So we've removed the utility meter. This model is to represent transformer, riser, meter socket, disconnect, and load. Now the Super Beast does not feed through. It's on the top only. So orientation is important. So we'll put it in the socket. The most important thing, just like a PMI recorder, we have to attach the neutral. The meter that we have, this meter doesn't have a neutral tag on it. So whether we're installing a PMI recorder or a Super Beast, we have to make a neutral connection. They're telling you, Super Beast people, stick this back in the meter socket and grab that neutral bar. Well, that's what we're going to do. I don't have a bare neutral back there, so I'm going to grab it right here. And we can see that unloaded, we have a balanced voltage. We'll bring these 2 light bulbs up, okay? Since this does not feed through, none of this is going to light up. There will be no power in the house. All of the load is created by the Super Beast. Transformer, service wire, riser, Super Beast, top lugs of the disconnect panel. Where we connect the neutral determines whether we're on the high side of a bad connector, low side of a bad connector. Right now, I know where the bad connection is. And the bad connection is in the service run to the house. So we're going to take the Super Beast and we're going to add this load to the right-hand side. We watch the voltage fall 1 to 91 on the loaded leg, and it rises to 148 on the unloaded leg. We turn the load off so that we have 0 amps. We go back to a balanced voltage. Now we're going to take that load that we had put on the right-hand side, and we're going to put it on the left-hand side. Now we watch the 91 move over here. The 147, 48 is now on the right-hand side. That's a guaranteed neutral connector. Guaranteed. Now, I have created the bad neutral connector in the service run. I'm going to restore that. Now what we're going to see is voltage drop only. And with a little experience, you'll get this. We watched the loaded leg fall to 112, but the other leg did not go up to 149. The reason we want to spend some time on this neutral connector, if the neutral is not connected, hanging in the clear, you can see that the voltmeters on the Super Beast are not working correctly. And when we go to add load, we'll push 245 all the way to one side. The other side won't even operate. We reconnect the neutral wire. Voltages are balanced. I see voltage drop caused by wire length, but I do not see what you would call a bad neutral connector. Now, let's say this has been really bad for a long time and her neutral is almost gone. So if we put this in the wrong place, and what I'm going to do is I'm going to open the neutral connection going into her house. The neutral connection going into her house is broken. When it leaves the disconnect panel underneath the meter, that wire is broken. But we're going to connect it over by the transformer. Voltages are balanced. We don't see a bad connector because of where we put the neutral connector. Now I'm going to put it, this neutral connector and this meter cannot see down line. So it has no way to know that this neutral is broken. I've got to get on the other side of it. So we're going to come over here. You haven't seen me open, close anything. I'm going to pin on this neutral connector past the break. Voltage is crap. 245 on one side, blank on the other, shows an open neutral. A little bit of experience, you'll learn to love the Super Beast. I'm going to close this neutral connection, either with a bypass jumper that I made, some way my voltmeter is going to show me the total. I'm going to close this and restore the neutral. Now let's say we have a bad pin terminal. And what I'm going to do is I'm going to open up a hot leg. We have good balanced voltages. It'll show you that that leg is open, right hand side. When we connect in the meter socket, it's already determined right hand side, left hand side. I'm going to open the left hand hot leg. But we must have current to troubleshoot a connection. The Super Beast provides that connection, provides that load to help us hunt that connector. So let's take and disconnect. The Super Beast is off. I'm going to pull it out of the socket. Now I'm going to put it in the adapter. Remember, I still got to do something with this neutral. When we go to a adapter, the neutral's coming to the socket by the cord. The manufacturer has a little metal clip and he wants you to clip onto that, but I found that it was difficult and inconvenient, so I built a little jumper. Now my neutral is tied to the neutral in this cord that I'm going to connect. I'm going to try to orient this so that you can see the Super Beast. And then we're going to work these 3 pigtails. Black is the right-hand side, red is the left-hand side. So I'm going to go ahead and connect black in the meter socket to the right-hand side. The red, left-hand side. Neutral in the meter socket. You can see that the Super Beast came online. We have an open neutral. That means I didn't do a good job putting it together. It came off the clip. Something happened. And usually it's the way that this got connected. See if our voltages are balanced. They're still trash. Come down here and get on this neutral load. Voltages are balanced. So the neutral connection is really, really important. Now we're going to disconnect this. Disconnect the hot legs. Disconnect the neutral. And we're going to stab the meter. As the co-op decides where our line stops, in a primary loop, we're responsible for the disconnect panel. That'll be up to your superintendents. So now we have transformer, service, riser through the meter into the disconnect panel. Disconnect panel's got load. So we know that the panel's hot. You can see here, we're going to take this. Remember, black is right. I like to be down here. That means I've tested everything. Black is right, red is left. Now I have to decide where to connect my neutral. I'm going to connect my neutral to the small bar and force that neutral current to go up through the companion bar, through the lugs, and back to the transformer. Right now, our secondary voltages should be good. I see a balance 122, 122. We're going to load. You should be able to see those bulbs as this is with a good neutral. That's the voltage drop that the bulb sees in normal times. Air conditioning compressor comes on, it falls to 111. 111 is a 9% voltage drop. And if they have a large air conditioner, that's not uncommon. We see it often. But that is not a neutral problem. It's a voltage drop problem. So now we're going to go and create this resistive bad neutral connector. Right now we have a balanced load. We have a light bulb on the right, a light bulb on the left. They use the same amount of current. There is no current on the neutral, and we don't have a neutral problem. The Super Beast added that load to one side. The voltage on the loaded side fell to 90 volts. 90 volts is a 25% voltage drop. And if you see how dramatic it was in the light bulb, the other one, that voltage went up. We're going to do it on the left-hand side now. Now we found that sometimes we have to let it run for a little while. I like to tell the story that we were working a voltage complaint in Nixon. I had an external load. I'm going to turn this power off. We had an external load. We were in the meter socket running 10, 11 amps. It took 15 minutes before the voltage changed, before the connector deteriorated to the point that we could see it with a voltmeter. Now, thermal imaging, infrared, we saw that connector long before it failed, in contrast to the hot connectors. So to wrap all this up, we'll have this board out here for a couple days. You can see how we have it set up. The Super Beast I'm promoting. I think that when we talk about the loads, the external loads that we would normally bring, the work that we asked Miss Smith to do, Miss Smith isn't home, she can't help us. If we have a Super Beast, we put it in the socket and we can work our way from the meter socket up, or if your superintendent tells you that we're responsible for that disconnect panel, we can actually leave the meter in, bring the Super Beast in, and clip into the bottom using the Super Beast and the meter socket base. So I like the product. I think that there's a reason every trouble truck in San Antonio has one. If you have any questions, contact me. Thank you.